All right, finally, let's take a little bit of time and look a little bit carefully at how TCP responds to bad events. We looked in the previous lecture about how it grows quickly when nothing bad is happening and you're just getting acknowledgments. But what does TCP do when you have a bad event? And that's going to be shown in this chart, which is an amalgamation. Basically, I've tried to simplify all the things that are shown on page 784. I believe page 784 in the text, unless the text changed from the last time I made these slides. So you have to remember a few things. First of all, there are two different modes. There is a slow start mode, and there is a you're in the slow start state, or you can be in the congestion avoidance state. And the slow start state is actually when you're growing exponentially, and the congestion avoidance state is when you're growing your congestion window linearly. And so here's what happens when you're in those different states. All right. If you're in the slow start state, let me get a pen here. Maybe a highlighter will work better this time. Let's go back to a highlighter. If you're in the slow start state and you receive an acknowledgement, then as soon as you receive that acknowledgement, notice this is kind of written in C here, your congestion window grows by 1 MSS. Typically the MSS is 1500 bytes. And then you ask yourself, hey, did my congestion window just get bigger than my threshold? Remember, the threshold was that kind of set value after which you're going to slow down a little bit. And if it is, then you go to congestion avoidance state. And if it's not, you just keep growing really quickly. And what this particular state does, when you're in this state, normally that doubles the congestion window every round trip time. And I'm going to encourage you to think about why that happens. I gave an example in the last slide fairly quickly. But think a little bit about why would the congestion window double every round trip time in this state? All right, I'll let you think about that a little bit. Then you're in the other state. This is the congestion avoidance state. This is the one where you're going to grow linearly. In other words, you're not doubling, but you're going to grow really you're just going to grow by one maximum segment size each round trip time. And so in this case, when you receive an ACK, you grow the congestion window, but you grow it by this formula, MSS times MSS over the congestion window. And this really if you do the math, this is MSS squared over the congestion window. Well, what that actually does is it says I'm only going to grow by a tiny amount, and it's the amount that of the MSS as proportional to the size of your congestion window. And here's what's going to happen. You're going to grow by 20 you're going to get 20 ACKs, and so you're going to grow by 1/20th each time, and you're going to end up growing by 1 MSS, and this creates linear growth per round trip time. So we have two states. We have the slow start state, and that doubles every time. This is basically your ×2 of your congestion window, and this is basically let me get a pen. Pen and black, please. This is plus 1 MSS every time. Okay? So now, it doesn't matter which state you're in. If you receive an acknowledgement, normally you do the thing that's described up here, depending on which state you're in. But if you get a triple duplicate ACK, now a duplicate ACK occurs when an intervening byte has been lost and the receiver receives a byte that's past the missing segment. He has to send the acknowledgement of what he's received contiguously. And he does send an acknowledgement. He just sends the same one over and over again. So when he sends 3 duplicate ACKs at the same time, then doesn't matter what state you're in, you do two things. First off, you change your threshold. You lower the amount by congestion window over 2. So whatever your current congestion window is, divide that by 2, and that becomes your new threshold, the point at which you change from exponential to linear growth. And then you change your current congestion window to the threshold plus 3 maximum segment sizes. And that puts you just a little bit above the threshold. Basically, this process cuts your current congestion window in half because you got triple duplicate ACKs. These are not horrible, but they're not good. So you're just going to say, okay, I'm going to cut back by half. And you stay in fast recovery, which is your normal, well, actually you stay in congestion avoidance, which is this one up here that grows just a little bit. Now let's say you get a timeout. A timeout is much, much worse. So if you get a timeout, you cut your threshold to half the current congestion window, and you cut your congestion window to a single MSS. So basically this goes back to almost zero, and you go back to the slow start state. And if you get a duplicate ACK, then in either case, then you just count. If you get up to 3, you do this case up here. But if you get 2 and then you get a regular ACK, then you say, okay, good, everything's back to normal. Okay. So here's a state diagram. You can look at the slides that are posted on Blackboard to see this as well. And this is going to try to give us an idea of what's happening in the different states. So when you're over here in the slow start state and you get a timeout, your threshold is set to the congestion window over 2. This timeout's bad. And your congestion window becomes 1 MSS. If you get an acknowledgement, then you grow the congestion window by 1 MSS. Now, look at this over here. If the congestion window becomes larger than your current threshold value, you change to the new state, congestion avoidance. Okay? And if you get 3 typical duplicate ACKs, then you are going to switch to fast recovery. Your threshold is going to go to congestion window over 2, and your congestion window is going to equal 3 times, I'm going to erase all ink on this slide. Okay? So that's what happens in slow start. What happens in congestion avoidance? If you get a timeout, look at this. You go back to slow start. Congestion window gets cut in half, and that becomes your threshold, and the actual congestion window gets set to 1 MSS. If you get a normal ACK, then you change by a very small amount so that you only grow by 1 MSS each round trip time. If you get 3 triple duplicate ACKs, okay, you go back to here again, and now your congestion window, your threshold is set to half the congestion window, and the congestion window is set to 3 times the threshold plus 3. Let's erase all that. Because how do you get from fast recovery? If you get a timeout in fast recovery, you go to slow start. But if your congestion window grows over the threshold, you move back to congestion avoidance, which it typically will do, right? And so duplicate ACKs will do this thing down here in the corner, right? So that shows you what's going on there. So let's do an example where we are looking at some of these and we see how these different things change. And I'm going to be, let's see if I've got nope, I don't. So I'm going to add a blank slide here. Unfortunately, the really sad, no, get rid of everything. Let's enter a blank slide, and now we'll go back to slide mode. Okay, this has almost already been too long, this particular segment. All right, so I'm going to page down and page up here. So the receive window is 6,000. That's how much the other person can receive. The threshold is 65,000. The last byte we sent was 0, and the last ACK we sent was 1. The last ACK we received was 1. The maximum segment size is 1,000, and we're in slow start. And the congestion window is currently then at 1,000. We're going to send 17,000 bytes before we get a timeout event. Okay, so I think this might actually be easier in a spreadsheet, but I know one thing I could do here. Let's go down here. Let's put a table in, and we'll go with 7 columns and a bunch of rows. Hopefully you'll be able to see this, okay? And we will move this guy right up here. Ooh, that doesn't look nice. Stop it. Sorry you have to watch this. All right. Should pause. All right, I'm back. We're going to flip back and forth between these two slides. Okay, so initially the MSS is 1,000. The last ACK we received is, okay, here's the last ACK. Last ACK received. And you remember that was 1. And the last byte we sent was 0. We haven't sent anything yet. Our congestion window starts out at 1 MSS, so it's at 1,000. And the threshold is 65,000. Okay? So we have been asked to send a whole bunch of data. And what we do is we look at our window size. Our congestion window is 1,000. Our last byte sent is 0. Our last ACK is 1. We can send up to from 0 to 1,000. So we send 1,000 bytes, and that makes that our last byte sent. The congestion window is still 1,000. The threshold is still 65,000. We have not received an ACK. Then we get an event where we wait a little while, and we get an acknowledgement. And that acknowledgement is 1,001 because we sent from 1 to 1,000, and so the acknowledgement is 1,001. As soon as we get that acknowledgement, our congestion window grows by 1 MSS and it becomes 2,000. The threshold does not change. That's 65,000. I didn't do that very well. And now, also, our window now goes from 1001, this guy, who's our last ACK, plus our current, let's look at the receive window. The receive window is that we've been getting all along from the other guy is 6,000. So our receive window is 6,000, and it's still 6,000. So we'll just Control C, Control V. Oops, I don't like the way that did that. And even down here it's 6,000. Oops. And so we look at what's the window size. It's either 2,000 or 6,000. We take the smaller of those two, and our current acknowledgement is 1,001, so we can send all the way up to 3,001. So we send bytes at 2,000, and we send bytes at 3,000, and the congestion window doesn't change, threshold doesn't change, last ACK doesn't change, and then suddenly about, let's say the round trip time is 40 milliseconds, so we get about 40 milliseconds later, we get an acknowledgement for 2001. And we immediately change the congestion window to 3000. And almost immediately, we get an acknowledgement for the next 1,000 bytes that we sent up here, and that's 3000, and now our congestion window is 4001, and the receive window is still 6000. So we compare these two and we go, hey, we can send 4,000 bytes. Well, our last ACK was 3001. Our window size is 4,000, and so now we can send bytes all the way up to 7,000. And so we send from 3,000 to 7,000. And when that happens, we're actually sending 4,000 bytes. Eventually, we'll get the acknowledgments from 3,000 to 4,000. And when that happens, our congestion window will grow from 4,000 all the way up to 8,000. But now we have a problem because we have a window size of 6,000. So even though our congestion window is 8,000, we're limited by what the other guy says he can receive. So we now can send 6,000 bytes per window, and so we send from 7,000 to 13,000. We get we eventually get acknowledgments for those from 7 to 13. And those acknowledgments, each one will cause us to grow our congestion window from 8 actually all the way up to, he'll grow by 6. So now he'll be 14K. But the receive window is still 6,000. So we're only going to send another 6,000 bytes. And we send 19,000 all the way up to from 13 to 19. And if we look at our example, we get a timeout. Something bad happens and we don't actually get an acknowledgement on these. So there's a timeout here, timeout. And what do we do on a timeout? Well, first off, we resend the data. But now let's go back and look at this. We're in slow start. We receive a timeout. The threshold becomes the current congestion window over 2. All right, so I take what's the current congestion window? The current congestion window is, would have been 14K. So the threshold now becomes half of that, 7,000, okay? And the next thing we do is the current congestion window becomes 1 MSS because we had a timeout. So now the congestion window goes back to 1,000, okay? And what else happens? That's it. We go back into slow start. And so now we start trying to send again, but now we can only send from 19 to 20. We get the acknowledgement for that. Eventually, we get an acknowledgement for all this stuff, and we get an acknowledgement at 20, and we can now change. Remember, our Kong win here was set to 1,000. So when the acknowledgement comes in, it can grow by 1,000, so now it's 2,000. We can now send another 2,000, so we can send from 20 to 22 in essence. When we get those two acts, well, eventually you can see, this isn't working too well. Eventually you can see that we will grow past the congestion window. When that happens, we're going to start growing more slowly. So the point of this is to try to give you a sense for how these numbers work together, and you will be expected to work some exercises that just do what I did here. You know, build a spreadsheet. That'll be better than this, and just work through it. Whenever there's an event, go to the event chart and change the values accordingly. All right, that should help you get through this.